Hi, welcome back everyone to yet another lesson in Python programming. In today's lesson, we are going to learn how to develop and design a SQL database using the Python programming languages. With that said, let's have a look at the objectives for today's lesson. The objectives include the following. First, we'll define relational databases. Next, we'll move on to exploring the SQL programming language. And then we'll have a practical demonstration in which we'll create a database using Python and SQLite. So, first of all, what exactly is a relational database? A relational database is a type of database that organizes data into one or more tables of columns and rows with a unique identifier associated with certain rows. The columns represent attributes of the data and the rows represent individual records. Relationships between different tables are established using columns, otherwise known as keys, to link the data. This allows for data to be queried and manipulated in a structured and an efficient way. In summary, the core characteristics of relational databases is as follows. They consist of tables, they make use of records and fields, and they constrain data using primary and foreign keys. So where does SQL fit into the broader picture? Well, SQL, otherwise known as Structured Query Language, is a special purpose programming language for accessing and manipulating data stored in a relational database. It is used for inserting, updating, querying, and deleting data in a database, and it can also be used for creating and modifying the structure of a database, such as creating, altering, and dropping tables, views, as well as indexes. SQL statements are used to communicate with the database and are the standard language for relational database management systems. The common features of a SQL database allow us to do the following: select data, update data, and insert data. This is what we'll be focusing on throughout the next couple of practicals. Now, there are various types of SQL database management systems. Among them, these tend to be the most popular: MySQL databases, Oracle databases, and MS SQL, or otherwise known as Microsoft SQL servers. Now, for the most part, the syntax, regardless of the database management system, tends to be near identical with a very slight variation. Let's take a look at the syntax of the SQL programming language for Oracle databases. In the following example, we are using SQL to create a table. Notice that in the first line, we call create table, followed by the table name. We then specify the columns that we'd like to embed inside of this table. For this example, we have customer ID, which is a data type of number and with a unique constraint of a primary key. Followed by that, we also have additional columns with various data types. In this case, varchar2 as well as number. Varchar2 is the standard for creating strings inside of SQL databases. Notice that we have other column names, including name, address, website, and credit limit. Here is another example of using the Oracle SQL syntax to insert data. In the first instance, we first specify the insert into keywords. We then specify the table name in which we'd like to insert data. We specify the column names of that specific table, followed by the values to be inserted under region ID and region name. In this case, we are inserting the value 1 for region ID and Europe as the region name. It's important to take note that for our practical demonstration, we are not going to be using the Oracle syntax. Finally, here is one last example for selecting data from our database using the Oracle syntax. We specify the select keyword, followed by the columns we'd like to select from our table. We then specify the table name that we are retrieving the columns from, and we can also add a where clause as an addition in the event that we'd like to restrict the data. In this example, we are retrieving the product name, the category ID from the products table, where the category ID is equal to 5. Now, for our practical demonstration, we are going to be using SQLite. SQLite is a library that provides a relational database management system and is embedded into software applications. It is a self-contained, serverless, and zero configuration database engine that is simple to use and requires minimal setup. This is also the reason we are going to be opting for SQLite inside of Python. SQLite is a popular choice for small and medium-sized applications that need a lightweight and portable database solution. This only strengthens the argument for using SQLite as opposed to any of the other database for our practical demonstration. Now, without further ado, let's dive right into PyCharm and let's start creating our database. In order to get started, we first have to create a new project. So I'll simply navigate to the File tab, New Project. I'll open this up, navigate to my production folder, right-click, New Directory. I'll rename this as Lesson 6. I'll expand this, click OK, select my interpreter, and click Create. I'll replace this window by creating the new project. I'll click on this to get rid of the breakpoint, clean up all the code, and now we are good to go. Before we start writing any code, I want you to take note that in my Explorer, under the project folder we just created, we only have two files, one folder and the main py. Now, when I create the database, that database is going to be created within this folder directly next to my main.py file over here. So I'll minimize this, and to create our database, we first have to import the SQLite module, which is a built-in module with Python. And I think that's quite nice because this does not require any sort of additional setup. Next, I'm going to go ahead and create a variable called con for connection. I'll set this equal to SQLite3 dot connect. Next, I'll pass in a parameter over here, which is the database name. In this case, that's going to be employee underscore database.db. We want to ensure that we add the extension .db at the end so that Python knows that we are working with a database. This is a requirement if we want to work with a SQLite database inside of Python. And on a new line, I'll simply just print a message, database has been opened. Great. Now take note that much like in one of our previous lessons when we worked with file handling, if I minimize this, we currently don't have a database in this folder named employee database. So if I run this code now, database has been opened is the output, and you'll notice that the database has been created inside of that folder. Wonderful. So the con variable I created at the top, I'll call, and then I'll call the execute function on that con variable or object. And the best way to make sense of the execute function is to think of it as a way to write SQL code. So the parameter that we pass into this function needs to be SQL code or SQL syntax or a SQL query. Now, what I'll do is I'll maybe just add a bit of space over here, and I'm going to wrap this SQL query in 3 quotation marks. So 1, 2, 3. Great. I'll then hit enter to provide a bit more space once again, and I can start writing my SQL code. Remember, this is no longer Python code. This is a SQL query, which means that we are now programming in SQL. So I'll start by using the create statement. If you remember correctly, we use the create statement in the event that we want to create a table, for example. So I'll say create table and provide this table with a name, which is going to be employees. And then on a new line, I'm going to open up a set of parentheses. I'll provide a bit of space here as well. And now I can start passing in the column names that I want to create for this table. The first one is going to be emp underscore ID for employee ID. This is going to be a data type of integer or number. And this is also going to be a primary key, which means it's going to be a unique identifier associated with the employee ID. So primary key, and this is going to be not null. Not null here just basically implies that when a record is created for this table, you cannot leave the specific field empty. On a new line, I'm going to create my second column. Notice that I used a comma over here as a separator. And my second column is going to be name of type text, which is also going to be not null, which means this is a requirement to be inserted when a record is created. And then a new column, department name, which will be of type char or character with a length of 40 characters, which also needs to be of not null, comma, and then a new column known as region and of type char once again or character with a limit of 50 characters, comma once again, and finally we'll have a column for salary, which will be of type real number. of type real just basically means that we can include decimal points into the specific salary field. And then I'll close my statement off with the parentheses we had at the bottom. And this is extremely important. I need to include a semicolon over here. What this basically implies is that this is the end of my SQL statement. To make things a bit more pretty, I'll also just bring my quotation marks up. So let's summarize exactly what it is that we've achieved here. We've created a table with the name of employees. We provided the column names for when this table is going to be created. Employee ID of type integer or number. This is a primary key and it should not be null or not empty. We then have a new column called name, which is of type text, also not null. We have another column, department name of type char. We have a column name region of type char as well. And we have a column name salary, which is of type real. Now at the end of this, I simply just want to print something just to make sure that we know that our table has successfully been created. So what I'll do is clean up my code a little more by wrapping up my statement. So everything in between my execute function parameter here is my SQL code. And then below this, I'll simply just do a print table created successfully. So let's just bring this back. Great. And then once we've achieved that, I'm going to close the connection. So I'm going to call the con object again, and I'm going to call .close function on this object. So after we've executed our statement, we then close the table, or we close the connection. So we open up that connection, and then we execute SQL code, and then we close our connection. So let's run our code and see what we get. So if I click run, everything works successfully. Notice that we have database has been opened, and that is as a result of this block over here. And we have table created, and that is a result of everything running successfully with our connection being executed. Now we can't really see anything inside of our database just yet because we don't have data inside of our database. In fact, all we've really done was just created the structure of our database. We still have to import data into our database. There is one thing worth noting. If I try to run this script again, I'm going to get an error, and that is because the table employees already exists. The only way to run this script successfully again would be to delete my database over here. So if we actually do that, and I now run this code again, my database will be created. So that is just something to keep in mind when you are trying to recreate a table or recreate a table inside of a database. And that is it for today's lesson in Python programming. In summary, we briefly defined the characteristics of relational databases. We also had a look at the syntax for SQL programming. We also explored some examples of the SQL programming language, and we managed to create our very first database. In our next lesson, we're going to start inserting data into our database so that we can actually visualize the data within our database. So for all of that and more, I'll see you in the next lesson. Cheers.